on problems that I think, well, this is a nice one, everyone will get points for this. And that idea of it can't be that easy pops in. And so if you ever see a question with a gift icon next to it, it is as easy as you think.
Awesome.
Thank you for that. I definitely second guessed myself way too much.
Now, I don't always remember the gift icon, but if you see the gift icon,
Because my immediate thinking is like you're a Dungeons and Dragons DM and you're just going to throw awful things at me constantly.
ooh.
Oh, no, what did
During
you
the
do?
test, suddenly I go, a dragon is now entered into the problem.
Roll for
And
initiative.
each person gets a different monster showing up at different times during the test. Any of you seen the movie Exam?
Wait, what was
Heard of it?
A bunch of people trapped in a room. You have one question only. You have 80 minutes to answer it.
Oh yeah, I think I've seen that before.
That's like an escape room.
Yeah.
Basically.
Well,
There was one similar to this that I watched.
they're trying to basically get a job. This is the last stage of a job interview. If you ever I've always wondered to see if I could, without people's lives being threatened or guns going off. I thought it'd be really cool if I could pull that off.
It's doing the final day of the semester.
He's young
But not a
Jigsaw
grade. If
mode.
you get right to extra credit.
If I were trapped in a room, that would already be enough for me to fail.
Seriously,
Let me out here.
escapers are retarded than you think.
All right, anyway, back to the hardest problem.
Is there gonna be something similar to this on the test?
I've done something similar to this on the test. It did not go well.
Was it?
A ball is thrown from a cliff at 40 meters per second. The initial speed is 40 meters per second at some angle theta. It lands 100 meters from the bottom of the, I think, a 50-meter cliff. At what angles was the ball thrown? There are two answers. As you work it out, potentially you'll end up with four answers, two of which won't make any sense.
You said angles.
Angles, plural. Is definitely within the scope of 151. However, for those people who have not had trig, it becomes a little bit trickier. And there's also, I was gonna say, an easier way of solving it than the harder. If you know trig well enough, there's a nice little trick that will save you a lot of time. If you are less comfortable with trig, then you can still get there. Anyway, I just want to do this as an example of it won't be harder than this. Because the projectile motion problems is just a matter of what do I give you and what are you trying to find? All right, so let's start out with, as with any of these, let's establish a coordinate system. I am going to force that to the right is positive. Up or down positive?
Up there.
I heard up, or saw the gesture up first, so we'll call that I hat and J hat. So I'll have my I hat coordinate, or quantities, and J hat. I've got my position, my displacement, initial velocity, final velocity, acceleration, and time. What do we know?
Initial for J hat is 40 miles an
Oh, initial,
hour. Placement, position, no.
Here we are.
Initial wait for the J hat, the displacement is -50.
all right. So negative 50, right here.
For
With the
I
displacement.
had the displacement.
100.
Sorry, there were two voices.
Alright, we're both saying the same thing.
Yes.
The
Now,
displacement
in
for I
unison
hat,
to be really nice. Okay.
the displacement for 100, or for I hat would be 100.
Meters.
meters.
Okay. See how easy this is?
Yes.
Now what? There are two more definite things we can put in there and two kind of things we can put in there.
The acceleration for J hat is negative 9.8 meters a second squared.
Yeah, let's go ahead and establish birth.
That's what does.
This is the thing that I do enough projectile motion problems and in my head I'm going, we've done this, they've done it already, I gotta add some twist to it. Let me put it on Mars. And you're thinking, wait, I don't know what the acceleration of gravity on Mars is. On a test or quiz, well, on a test, you look at the first page, on the quiz, you look at the top. And if I didn't provide it for you and you need it, just ask. So negative 9.8 meters per second squared, okay?
The acceleration for, oh, sorry.
No, go ahead.
The acceleration for I hat would be 0
Meters per second squared.
meters per
There.
second squared.
You just hate units, don't you? All right, so that's all the definite information that we know, now the sort of information. Nayeli was starting on it and then you veered off because you got a little intimidated or something. I do have one other piece of information stated in the problem, but the question is how does that go in there? One of you.
The initial velocity for I have would be 40 cosine theta. We don't know what the, and then 40 sine theta. Yes, meters per second.
All right, yes. And that's the tricky point. There are a number of difficult physics problems that you start into and you're thinking, am I doing this right? And you just have to have the faith that you're going about it right. Because you can get partway through it and still be questioning yourself, and that's a path to madness. There are enough paths to madness in physics. Just believe in yourself that you're doing it the right way. And then after an hour or so, you realize, oh, this is the wrong way. Then you go back and try again. Which is so easy to say. And on the test, there's the psychological factor of, I can't take any more. If you're not quite sure how we got cosine and sine there, let's zip that up. I did start that thing, right?
Yeah.
Okay, thank you. I have a hypotenuse that is 40, an angle here which is theta, and I'm trying to find the perpendicular components. My coordinate system is set to horizontal and vertical, so I find coordinates that are horizontal and vertical for the components. This is the adjacent side, and the adjacent side is going to be the hypotenuse times the cosine of the angle. The opposite side, think of SOHCAHTOA sine, opposite side is the hypotenuse times the sine of theta. I did skip a step there, so dramatic pause for questions.
Are we assuming that that's a, right degree angle?
Yes, we are making that assumption because these should be perpendicular to each other. Let's make that more explicit. Whereas one teacher said it's the mom angle because it's always right.
Who solved those to get theta, either one to get theta?
All right, so let's actually get into the solving because we're trying to find theta. Recognize that sine theta, with most algebra problems, you have an unknown, you isolate it, and you solve for it that way. With trig functions, you need to isolate cosine of theta or isolate sine of theta first, and then solve for theta. But we have to isolate the trig function first. All right, so what we're gonna do is, we're gonna just plug into the equations there and see what pops out of it. Now, if you already know which ones to use, great, and if you don't, well, we'll just plug in. So I'm gonna set up, plug in the I hat stuff. So the first one, I have 40 cosine theta I have V final is 40 cosine theta plus 0 times time, which doesn't really help us a whole lot, but it's a true statement. The next one we have our displacement, 100, is equal to 40 cosine theta plus Vf over 2 times time. The third one, we have 100, is equal to 40 cosine theta t plus 0. Technically 1/2 times 0 times time squared. And then the last one, Vf squared is equal to 1600 cosine squared theta plus 2 times 0 times 100. The only thing that really is gonna help us here, the first one tells us that our final velocity is the same as the initial velocity. That should not be a surprise, I hope. The acceleration is 0, which means that horizontally, which means that velocity component does not change. This one, we plug in, we still have theta and time as unknowns. Actually, we have theta and time as unknowns all across the board. So this will just tell us that 100 is equal to 40 times cosine of theta times t, which is the same thing that this tells us. So first and third one tell us that the final velocity and initial velocity, actually final velocity equals initial velocity. This tells us the final speed equals the initial speed. And these two both tell us that 100 is equal to 40 cosine of theta times time. That's what these two tell us. That's the equation, that's one of the equations we're gonna use. However, I have two unknowns. So how many equations do I need? As long as they're independent. All right, the second one. I have Vf, so this is my j hat stuff. Vf is equal to 40 sine theta plus or minus 9.8 t. I have three unknowns there. The next equation is my displacement. Oh, I know what my displacement is. Negative 50 is equal to 40 sine theta plus Vf over 2 times time. Three unknowns. The next one, negative 50, is equal to 40 sine theta t minus 4.9 t squared. I just did the 1/2 a. A is 9.8, half of that is 4.9. And then the last one tells us that the f squared is equal to 1600 sine squared plus 2 times negative 9.8 times negative 50. These equations have three unknowns in it, really not gonna help. If we use one of those, that means we need a third equation, so those are not really gonna help us. This one, if we use this one and this one, we have three unknowns, because this has theta and time as our unknowns. This has Vf and theta as unknowns. So if I use those two equations, I've added an extra unknown, I would need a third equation. This one, on the other hand, has the same unknowns as that one. So those are the two equations we're gonna use. It's still using that often used third equation over there. And we have two equations, two unknowns. Dramatic pause, 4 questions.
So are we going to turn the equation from j hat to say that t is equal to this function and plug it into the t for the I hat to find that? Is that what we're gonna do?
Yes. As long as when you're creating the equation, you use the same type of thing. So I'm using only I hat numbers here, only j hat numbers here. All right, so I got 100 equals 40 cosine theta. All right, now we get into handwriting. I want to limit the amount of handwriting I have to do. I'm going to use a convention here. I'm just going to let the letter C represent cosine of theta, and I'm going to let S represent the sine of theta. It just makes the notation easier for me. And so I got 100 is equal to 40 CT. And I have negative 50 is equal to 40 ST minus 4.9 T squared. Think I'm trying to, yeah. So I have to solve for C, S, or, well, I can solve for T. I can get rid of time easily enough. Which I think was what Robin was suggesting. So what is time equal to?
100 divided by 40c.
Okay? Or that, we'll keep it. 5/2 of 5/2c. Just reduced it. If you want to keep the big numbers, keep 140, go for it. Plug that into the second equation. I get negative 50 is equal to 40s 5/2c minus 4.9 5/2c squared. Officially, I have one equation, one unknown. The trouble is I have cosine theta and sine theta. So it's kind of like I have two unknowns in the fact that I do need to solve for either cosine or sine. The question is, which one do I solve for? And how do I combine them? What is the relationship between sine and cosine?
Sine divided by cosine is equal to tangent. Is that
Okay, let's put that over here for the moment. Sine of theta over the cosine of theta is equal to the tangent of theta. Is there any other relationship between sine and cosine? If I use this one, I'm suddenly, yes, I can get rid of sine or cosine, but now I have tangent in there.
It's like sine squared equals 1 minus, or I don't know if it's like 1 minus cosine squared or something like that.
Yeah.
There's those relationships.
something like that.
I don't remember all of them though.
All right, let's think about what sine and cosine are. I know that if I have a triangle here, theta, and that's A, B, and C. I know A squared plus B squared equals C squared. That's a right triangle, Pythagorean theorem. If I divide everything by C squared, C squared, C squared, and C squared, I get 1 over here on the right. On the left, I get A over C quantity squared, so this 1 is equal to A over C squared plus B over C squared. And A over C, that's just the adjacent over the hypotenuse. That's the cosine. B over C, that's the opposite, over the hypotenuse. That's just the sine. That's the relationship. So using that, solving for sine or cosine, which one do you want? Do you care? Anyone with an opinion? So solve for cosine? So, well, I guess I have two equations. I was thinking in this one. So cosine of theta is equal to the square root of 1 minus sine squared theta. And that's what we'll solve. Let's go for. So I've got this 5 over 2 times 40 is 100, so I got negative 50. 100 sine over the square root of 1 minus sine squared. Minus 4.9 times 5.2 squared. If somebody would be kind enough to 4.9 times 2.5 squared.
What's under the square root? That's something minus sine of.
1 minus s squared.
Y, okay.
11.15. Is that what you said? Divided by c squared, which is 1 minus s squared.
What's that? 4.9 times 5 square divided by 2 square?
Yes.
I got 30.6.
Ah. So you had 13.60.
30.63. Not 13. 30.63.
30.63. So we have a difference of opinion here.
I got 32.
You have the 30.63?
Yeah.
Oh, I got the wrong. Ignore me. I know. I did.
Okay. If I had thought for a moment, the other one would have made sense that it didn't work. Because 2.5 squared is 6.25 times almost 5. I should have a number around 30. All right, so I now have one equation and one unknown, or I guess one trig function. All I